The reality of human life is that we're subject to a host of uncontrollable natural disasters that are imminent.
Yes.
They're going to happen.
Yes.
Yellowstone's going to blow.
Deep in the heart of America's untamed wilderness lies a sleeping giant that has captured the attention of the world's greatest scientists. Its raw beauty, awe-inspiring landscapes, and abundant wildlife draw visitors from around the globe. But beneath the tranquil facade of Yellowstone National Park, an ancient force lurks, ready to unleash its terrifying power. With the latest research and insights from top experts, Joe Rogan has just received terrifying news on the state of Yellowstone and why the national park had to be hurriedly closed down recently. According to the famous podcaster, Yellowstone is on the brink of something cataclysmic that hasn't been witnessed in thousands of years. Yellowstone's supervolcano is showing ominous signs of waking up, and in the blink of an eye, this beautiful paradise could turn into an apocalyptic nightmare. But what exactly has Joe Rogan discovered about the state of Yellowstone? And just how could the impending disaster at Yellowstone reshape the history and topography of our planet? Join us as we unravel the secrets that Joe Rogan has just uncovered about the state of Yellowstone and the terrifying events that are on the verge of unfolding. Yellowstone National Park is a vast and captivating natural wonderland situated primarily in Wyoming, but its beauty spills over into the neighboring states of Montana and Idaho. It encompasses an expansive area of over 2.2 million acres, offering an abundance of natural marvels that will leave you in awe. One of the park's most celebrated attractions is its geothermal wonders. Imagine more than 10,000 geysers, hot springs, mud pots and fumaroles, creating a captivating spectacle. Among them, the renowned Old Faithful geyser stands tall as a true wonder, faithfully putting on a stunning show. This iconic park is also home to the breathtaking Grand Canyon, which was masterfully carved by the Yellowstone River. But amidst this seemingly idyllic facade, a silent terror lurks beneath the surface, as Joe Rogan is now warning, the Yellowstone supervolcano. This colossal volcanic structure is classified as a caldera, an enormous crater formed by the collapse of a volcano after a massive eruption. Stretching approximately 45 miles in diameter, it exhibits the vast scale of this volcanic system. In his recent podcast with fellow podcaster Michael Malice, Rogan buttressed scientific claims that the caldera's formation can be traced back to ancient volcanic eruptions that transpired millions of years ago. Corroborating existing studies by experts, Rogan agrees that these cataclysmic events expel tremendous amounts of volcanic material, causing the volcano to collapse upon itself and giving rise to the awe-inspiring caldera we witness today. However, what remains visible today is merely the remnants of the initial explosion that shook Yellowstone to its core. This extraordinary volcano was truly one of a kind, as it constantly releases heat from deep within the earth. Everywhere you gaze upon the historic national park, you'll find hot springs, geysers, mud pots and fumaroles, all of which are vents that actively emit steam and gases. Rogan believes that these geothermal features exist because of the volcano's intense heat and geological activity. One of the most famous sights in the park is Old Faithful, a geyser that erupts with remarkable regularity. It shoots scalding hot water and steam high into the air, often reaching impressive heights of over 100 feet. But here's what's more shocking, as Rogan himself recently revealed in one of his widely publicized podcasts. Apparently, despite the fact that the Yellowstone supervolcano had its colossal eruption around 640,000 years ago, the region is far from dormant. It buzzes with constant activity, including small earthquakes and sporadic eruptions from the geysers. In fact, every year, thousands of small earthquakes are recorded in the surrounding area. Rogan believes that this is an indication of the ongoing movement of molten rock beneath the surface. It's like the Earth's way of warning us that danger may be lurking beneath, although it may not stay that way forever. And, like Rogan also explained, scientists who study Yellowstone take these warnings seriously. They employed sophisticated monitoring systems to investigate the behavior of the supervolcano and gather critical data for potential future eruptions. These methods allow them to closely observe seismic activity, ground changes, and gas emissions, providing valuable insights into the complex dynamics and nature of the supervolcano. To measure ground vibrations caused by seismic waves, scientists use instruments called seismometers. A network of seismometers is strategically placed throughout Yellowstone and its surrounding areas. These devices can detect and record even the slightest earthquakes and ground tremors associated with volcanic activity. And by analyzing the seismic data, scientists can determine the precise location, depth, and magnitude of earthquakes, aiding their understanding of magma movement and potential volcanic processes. Another tool used by scientists is the Global Positioning System, or GPS. Scientists use this instrument to monitor ground deformation around the Yellowstone supervolcano. Using satellite technology, these instruments can precisely track and record even the tiniest changes in the Earth's surface position. By comparing measurements over time, Rogan explained that scientists can detect any shifts or alterations in the landscape, indicating potential volcanic activity. GPS data is particularly valuable for understanding magma movement beneath the surface and identifying patterns and trends that could serve as precursors to eruptions, enabling scientists to take preventive measures. And in addition to seismometers and GPS instruments, gas monitoring stations are also strategically placed within Yellowstone National Park. These stations measure and analyze the composition and emission rates of gases released by the supervolcano, and the data derived from them helps scientists gain insights into the volcano's behavior and its potential impact on the surrounding environment. The gases emitted by volcanoes, such as sulfur dioxide, carbon dioxide, and hydrogen sulfide, can provide valuable information about underground volcanic processes. Changes in gas emissions can indicate how magma is moving and interacting with the surrounding rocks and fluids. If there are any significant deviations from the normal levels or signs of increased volcanic activity, researchers are the first to notice. By integrating this information, scientists can identify any anomalies or patterns that might indicate a significant change in volcanic activity. As likewise emphasized by Joe Rogan and Michael Malice in Rogan's podcast, where Malice was a guest earlier this year, this continuous monitoring has allowed scientists to uncover that volcanic systems are highly intricate and numerous factors can influence their behavior. As such, the ongoing research and data collection efforts contribute to improving scientists' understanding of the dynamics of the Yellowstone supervolcano. Rogan is convinced that without these efforts, we would be unaware of the potentially hazardous activity and the ticking time bomb occurring right beneath our feet. In another captivating episode of his podcast, Joe Rogan described supervolcanoes like the one at Yellowstone as those that have experienced significant eruptions in the past. He highlighted the distinction between these super eruptions and smaller volcanic events, emphasizing the magnitude and impact of supervolcanoes. Super eruptions are classified as VE18 on the Volcanic Explosivity Index, signifying their extraordinary explosiveness and the substantial amount of magma involved. The Volcanic Explosivity Index is a standardized scale used by scientists to measure and classify volcanic eruptions based on their explosiveness. The scale enables a comparison of eruptions using various factors, such as eruption cloud height, volume of erupted material, and duration of the eruption. Ranging from 0 to 8, the VEI scale categorizes eruptions, with 0 representing the lowest level of explosivity and 8 symbolizing the most violent and catastrophic events. Each VEI level corresponds to specific eruption characteristics, enabling scientists to estimate the intensity and impact of an eruption. This assessment takes into account factors like the height of the eruption column, the duration of the eruption, and the volume of ejected volcanic material. These parameters are determined through field observations, satellite imagery, and analysis of deposits left behind by past eruptions. At the lower end of the scale, when we're talking about VEO2 eruptions, they tend to be quite small in size and confined to a specific area near the volcano. The impact they have is limited, not extending far beyond the immediate vicinity. Rogan explains that these eruptions usually produce modest ash plumes and release a relatively small amount of volcanic material. But as we move up the scale to levels 3 and 4, things start to become more explosive. The eruptions gain more power and can generate taller columns of eruption. The volume of material being erupted also increases, which can result in the formation of pyroclastic flows. These fast-moving avalanches consist of hot ash, gases, and rock fragments, and the eruptions that follow often have significant regional impacts and affect a lot of activities, including air travel and agriculture. When the VEI level reaches 5, we're looking at large eruptions. They produce substantial ash plumes that spread extensively. The impacts of these eruptions can be widespread, affecting a large area surrounding the volcano. They can cause disruptions to transportation infrastructure and profoundly affect the environment. But things truly escalate beyond the immediate vicinity of the volcano when we reach the highest end of the scale, level 6 to 8. Rogan explains that this is where super eruptions occur, and they are the most catastrophic and rare events. These eruptions are characterized by colossal eruption columns that can reach the stratosphere, piercing through the sky with unimaginable force. Scientists have also looked into the immense and formidable challenge of accumulating an enormous volume of magma in a singular location. According to Rogan, this crucial factor serves as the catalyst for triggering super eruptions, which are often events of catastrophic proportions. The experts underline the inherent complexity and extensive time required for this process to unfold. It demands a gradual magma buildup beneath the Earth's surface, transpiring over an extended period. As this concentration of magma amasses within a reservoir, the potential for a super eruption looms closer. Super eruptions possess the ability to unleash colossal quantities of volcanic ash, propelling it skyward to staggering altitudes, reaching up to 80 miles above the Earth's surface. The dispersion of these ash particles over vast distances can have profound consequences on global climate patterns. According to Rogan, when volcanic ash is forcefully injected high into the atmosphere during a super eruption, it engages in intricate interactions with air currents and weather systems. These minuscule ash particles can remain suspended in the air for an extended period, carried across immense regions and even entire continents by prevailing wind patterns. As the ash disperses through the atmosphere, it comes together to form a dense cloud, almost like a forbidding veil that absorbs and scatters sunlight. This phenomenon, known as volcanic winter, transpires when the presence of this thick volcanic ash cloud considerably diminishes the amount of sunlight that reaches the Earth's surface. Rogan believes that this reduction in solar radiation exerts profound effects on the planet's temperature and weather patterns. The ash particles act as a formidable barrier, reflecting incoming sunlight back into the vastness of space, resulting in a temporary cooling effect on the Earth's surface. The cooling effect in turn triggers notable alterations in rainfall patterns and winds, creating disruptions at both regional and global scales. The consequences of such global cooling can extend far and wide, with agriculture and food production bearing the brunt. Changes in growing seasons and reduced crop yields may impede these vital sectors. Also, the delicate balance of ecosystems may be thrown into disarray as species grapple with adapting to the altered conditions. And beyond the environmental impacts, the cooling effect induced by volcanic ash can also reverberate throughout human societies, giving rise to a host of challenges. Economic hardships, resource scarcity, and social upheaval become distinct possibilities in the wake of such an event. Rogan believes that by drawing upon data accumulated over years of extensive research, scientists can make noteworthy observations regarding the composition of the magma beneath the Yellowstone region. But in order for an eruption to materialize, a higher proportion of liquid magma is necessary. Their analysis indicates that a minimum threshold of 30% liquid magma is required to create the conditions suitable for an eruption. Astonishingly, Yellowstone already surpasses half of that amount, suggesting an eruption may transpire sooner than anticipated. And if the volcano were to unleash its fury, it could potentially decimate everything in its path. But what does this mean for us? In Rogan's opinion, the eruption of this supervolcano could unleash devastation on a scale we can hardly fathom. Do you think our planet could witness the eruption of a supervolcano soon at Yellowstone? Let us know your opinions in the comments below.